Really connected to the remainder theorem is something called the factor theorem. If your remainder is 0, you have a factor. This is what we're going towards. We're going towards being able to factor bigger things. So if we can get a remainder of 0, then we'll be able to tell if something is a factor. So just like the factor theorem, just like the remainder theorem, if you want to find out if something is a factor, you need to find a remainder of 0. So for the very first one, again on here, I'm going to call this let p of x equal. For the very first one, it's a 1, so I'm going to show you both methods. If I want to use the remainder theorem for A, I would plug in -1 in for x, and then this mental math is not very difficult at all. A negative cubed, this will still be -1. A negative squared will be positive times that -6 minus 6. 5 times -1 minus 5 plus 12 equals 0. It is a factor. We can see that with the remainder theorem. We can also see it using synthetic division. 1 minus 6, 5, and 12. Again, I double check that they're in the right order, and I double check that no degrees were missing. I'm dividing by x plus 1, so -1 would be out in front. Bring the 1 down, multiply, add, multiply, add, multiply, add, and sure enough, I get that remainder of 0. Now I'm going to come back to each of these at the end, so I would like you to leave a little bit of space, maybe about enough for 2 lines after this before we go to B. We'll fill out one of the lines. I want you to write the division statement. If I use my synthetic division, the nice thing, better than the remainder theorem, is I could write my division statement. So my divisor was x plus 1, and my quotient is x squared minus 7x plus 12. We're just going to leave that division statement and then leave room for one more line after that. We're going to come back to this at the very end. So for A, I definitely would, if I was asked to find out a remainder, for A, I could definitely see remainder theorem or synthetic division being equally worthwhile to use because the number was a 1. For B, C, and D, I definitely go to synthetic division because the numbers are bigger. So for B, I'd set it up. My setup. Still have my numbers 1, -6, 5, and 12. And this time I am dividing by x minus 3, so there would be a positive 3 out in front. Bring down your 1. Multiply, add, multiply, add, multiply, add. We've got a remainder of 0. That tells us that x minus 3 is also a factor. And since I use synthetic division, I can write my division statement. My divisor was x minus 3, and now my quotient is x squared minus 3x minus 4. Again, Leave a space for one more line there. We're going to come back to each of these at the end. So once again, if the remainder is 0, you have started to factor this. Synthetic division part C. We still have the same numbers of 1, -6, 5, and 12. And in part C, we're dividing by x minus 4. So we put a positive 4 out in front. Bring down the 1. Multiply and add. Multiply and add. Multiply and add. And once again, we get a remainder of 0. So x minus 4 is also a factor. I can write my division statement. X minus 4 times by x squared minus 2x minus 3. Leave space for one more line. Kind of crazy. It's not typical of a textbook to have the first 3 examples all work to be factors. Usually they mix it up, right? They kind of like, we want to show you one that works, we want to show you one that doesn't work, then show you another one that works. So let's try the last one. It was 1, -6, 5, and 12. This time we're dividing by x plus 4, so there'd be a minus 4 out in front. Bring down the 1, multiply, add, multiply, add. Oh my goodness, it got to some big numbers. We get a remainder. The x plus 4 is not a factor. But we did find 3 factors. And everybody got this down? I'm going to scroll back up to the top. We found out that x plus 1 was a factor. We found out that x minus 3 was a factor. And we found out that x minus 4 was a factor. And finding out all 3 of those factors is actually factoring that x cubed perfectly. X plus 1 times x minus 3 times x minus 4. If you multiplied that all out, you would get x cubed minus 6x squared plus 5x plus 12. I want you to notice something. First of all, if you were asked to multiply this out using grade 9 math, do you see that you would choose any 2 of them and multiply them first? And then you'd have a whole bunch of arrows to multiply in the end? And you could do that. I'm not going to get you to do it right now to double check, but you could. Okay? But I want you to notice some very important patterns. Important pattern number 1, which is very connected. Like, you know when we distribute one binomial times another binomial, sometimes in English we say FOIL, because you multiply the first ones, the outside ones, the inside ones, and the last ones. If you have 3 of them, we can make up a new acronym. It'd be like, FOIL. It sounds something like that, because there's a whole bunch of arrows now. It gets a little bit crazy. A whole bunch of different outsides and insides. But from it, I want you to notice the following. Look at just the first ones, not with an eraser, because that will make them go away. Let's see, make that, oh, it just, I wanted just to erase this and still have this x plus 1. There we go. But if you just look at the first ones, you see that my first ones are all x's. And if you do x times x times x, do you see that you would get x cubed? Make sense? X times X times X would give me X cubed. More importantly, check out the last numbers. If something factors beautifully, like this one factored perfectly, my last numbers, 1, -3, and -4, do you see that they make plus 12? Okay? This is going to be extremely important because you can answer the following questions now really quickly without having to do remainder theorem or synthetic division. If I said, is x plus 5 a factor of this? You could say automatically right away, no. Because there's no way that I could have a 5 as one of these last numbers and have them multiply nicely without going to fractions or decimals to get 12. So 5 will not be a factor. 7 will not be a factor. But if someone said check x plus 6, you're like, ooh, it might be. Because 6 works into 12. This is going to be a hint for us to figure out factoring. In this question, it didn't ask us to factor, it asked us to check them. All 4 of these were possibilities. But what we're going to find in factoring is that if you find one that works, like as soon as I found out here that x plus 1 was a factor, check this out. And this is the line I wanted you to add afterwards. I could rewrite the x plus 1, but now I have a binomial which you already know how to factor. X squared minus 7x plus 12. Would you agree that it has to be x and x? And what are my last numbers going to be that make 12 so that my outside and inside make minus 7? Minus 4 and minus 3. Does that match up? It does. We could have found all the factors if we would have just written the division statement and then kept factoring. Check out the second one. We left space for the second one. P of x equals. I'm going to rewrite the x minus 3. Can I factor this? Well, it would have to be x and x. To get 4, I'm going to go 4 and 1. I need a minus 3, so my 4 would be negative, my 1 would be positive. Exactly the same 3 factors. And if we did the same thing with part C, rewrite the x minus 4. This would have to be x and x. To get 3, I'm going to go 3 and 1. I need a negative 2, so my inside negative 3x. I get the exact same 3 factors no matter which one I choose. So now we're going to get into questions that start very similar to this, but don't have an A, B, C, and D. They just say, could you factor this? And the hardest part is to find the first one that works. So you look at the 12. You're going to look at that 12 and say, if something works, then these last numbers have to multiply to get 12. How many options are there? 1 and 12, minus 1 and 12. 2 and 6, 3 and 4, and positive and negative for both of them, because it could alternate signs all the way through. Usually people start with the small numbers. Start with the ones. Test all the ones. See if any of them work. If one of them works, like x minus 1 worked, boom. You can factor it all the way. But you're going to have to look at that last number to try test values to find the first one that works. Does it matter if your friend found x plus 1 and you found x minus 3? No. Whichever one you find, you can write the division statement, and then you can keep factoring. And this is what we're going to do in example 3, but first I'm going to give you 2 numbers to work on, 10a and 12. 12, I put a star beside it, because there's a strategy where you can work backwards. So make sure you look over question 12. And what we were just talking about there, I'll include it in this video, is this idea of a factor property. And they give this example at the bottom. They say if you wanted to factor x cubed plus 2x squared minus 13x plus 10, look at that plus 10. The only options that multiply nicely to get 10 are 1, 2, 5, and 10. And this is called the factor property. That if something is going to be a factor, then the factor itself, look at the factors that end up here, the numbers that are included in those last numbers have to be a factor of 10. And this will lead us to a strategy for factoring completely.